You clicked on this video because you saw the leaked metrics for Google's new Omni-Video model and you want to know if it actually works. The real stakes here are whether this technology solves the fundamental problem of AI hallucinations or if it just hides them behind smoother text. By the end of this explanation, you will understand exactly why the reported coherence improvements might be a smoothed-over illusion rather than a true leap in reasoning capability. The story of the leaked Omni model is more complex than the headlines suggest. What many observers are calling a singular Google breakthrough is actually a conflation of several independent research projects, primarily Omni-Video 2 from Fudan University and OmniHuman.5 from ByteDance. These systems are not the same product, yet they share a common architectural goal that addresses the very bottleneck you are worried about. The core issue with current video generation is that models often prioritize visual fluency over logical consistency, creating videos where the narrative makes sense visually but falls apart the moment you try to follow a complex instruction. To understand why this matters, consider how traditional models handle text. They often rely on autoregressive token prediction, which is like reading a book one word at a time and hoping the next word makes sense. This approach is prone to drifting away from the original prompt, leading to what engineers call semantic hallucinations. The new Omni variants attempt to fix this by shifting to a diffusion-based latent alignment. Instead of predicting the next token, the model starts with noise and iteratively refines the video until it matches the text instructions perfectly. This architectural shift fundamentally changes how the model fails. Where older systems produced logical inconsistencies, these new systems produce context drift, a subtler error that non-technical users might mistake for high-quality reasoning. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Here's the thing that changes the entire conversation. The improvement in text coherence you are hearing about comes from the use of multimodal large language models, or MLLMs, as a conditioning layer. Before the video generation even begins, the MLLM translates your user instruction into an explicit target caption. This acts as a guardrail, ensuring the visual generation stays aligned with the intended narrative. On benchmarks like 5e, which test complex editing tasks, this method has shown significant gains in maintaining text coherence across long sequences. It allows a non-engineer to generate a video where a character walks through a door and then sits in a chair, without the AI inventing a third chair or forgetting the door entirely. However, this solution introduces a trade-off that is critical for anyone considering adoption. By prioritizing narrative flow, the model often sacrifices specialized reasoning depth. The system becomes incredibly good at making things look smooth and consistent, but it does not necessarily understand the underlying logic of the scene. This is the distinction between generating a coherent story and actually reasoning about the physics or causality of that story. When you ask the model to generate a video where a glass falls and breaks, the model can make it look perfect, but it might not understand that the glass must fall from a height or that the sound must match the impact. Now consider the evaluation suite known as OmniR. This framework tests cross-modal reasoning, asking the model to answer questions that require linking visual events with textual logic. The results from OmniR reveal that even with these advanced MLLM conditioned diffusion backbones, the models still struggle with cross-modal reasoning. They can maintain long context attention across video frames, which previously required complex retrieval, augmented generation pipelines, but they do not yet possess the rigorous logical depth needed for factual storytelling. The bottleneck has not been solved, it has been smoothed over. The model prioritizes fluency, making the output feel more intelligent than it actually is. This leads to a crucial insight for your decision-making process. The coherence metrics you saw in the leak correlate with the model's ability to maintain context, not its ability to reason. For creative writing or entertainment, this is a massive win. You can achieve complex video text consistency without manual prompt chaining or post-processing. But for applications requiring factual accuracy, like educational content or technical documentation, the risk remains. The model might generate a video that looks perfect and tells a consistent story, yet contains subtle logical errors that only a human expert would catch. The final piece of this puzzle involves the latency of these systems. Production adoption will depend on the balance between inference speed and generation quality. If the model sacrifices processing speed to maintain high-fidelity text alignment, it becomes unusable for real-time applications like live streaming or interactive avatars. The reasoning bottleneck for non-technical users in these scenarios remains unresolved. You get a better video, but you pay for it with time and computational resources. The distributed nature of these academic achievements means that while the technology is advancing rapidly, the gap between smooth generation and true understanding is still wide. So, what does this mean for the future of video generation? The Omni architecture represents a significant step forward in making complex editing accessible to everyone. It removes the technical barriers that previously required specialized pipelines, but it does not eliminate the need for human oversight. The model is a powerful tool for narrative generation, but it is not a replacement for human reasoning. As you evaluate these tools for your own projects, look beyond the coherence scores. Ask yourself if the model's strength and fluency is sufficient for your specific needs, or if you require the deeper logical rigor that current systems still struggle to provide. The technology is impressive, but it is not magic. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.